Steam locomotives in miniature at the steam workshop, fitting the V1 footplate parts and piping up the steam brake. The footplate arrangement on this V1 is a little bit strange. None of the three plates that make up the footplate are secured to the engine in any way. Even the important parts like the steam brake column and the manual handle to rotate and apply the brakes are not fastened to the main frame, which is a bit weird, but when it's all together I'm sure it will work fine. The original piece of pipe that connects the steam brake cylinder to the steam brake column is a bit of a mess. It's been bent many times, and it's a very strange arrangement. You put the pipe in place on the steam brake and the steam brake column, and then squash the whole thing into position on the footplate, which bends the pipe just a little bit too far. So I'm going to change the piping arrangement because I just don't like this. Just look at the state of this pipe when I remove it from the column. The pipe is so badly kinked I can't see that much steam is going to get to the steam brake, so I'm going to make a new part for this. The steam brake cylinder is under the main part of the floor, quite difficult to get to. Here's the original pipe and here's the one that I made. When I put the pieces of pipe side by side you can really see the difference. The coil in the copper pipe allows for flexibility without kinking the pipe. I had to reuse the original nuts because a standard 4x40 nut wasn't a good fit on the thread on the steam brake column. Plus it's always good to keep some of the original parts, and here you see the principle. Everything's fastened together. I can push the footplate into position without any fear of mangling the pipe, because all of the bending forces are taking place in the coils at the end of the pipe. Once the footplate is in its correct position, I can connect the steam feed pipe to the main steam brake column. In this clip I'm moving one of the side plates into position, and the side plates are held to the centre part of the floor by some small brass countersunk bolts. Here's one of the countersunk bolts in place, and as if by magic here is the other one. I turned the engine round, which is not the easiest thing to do. This engine really weighs a lot. The steel boiler is much heavier than a copper boiler. The manual brake column has a thread that goes down into this fitting, but before putting it all together I'm using some steam oil to lubricate it. I often use steam oil for these applications because it's so thick it tends to stay where it's put and doesn't run everywhere, and generally it's a very good quality lubricant. The mystery of the floating footplate was solved when I put the bunker tank in place. It's the bunker tank that holds everything together. So now the footplate feels like it's attached to the main frames. Here's a wide shot of the engine, and as you can see it's starting to look good. The side tank is only loosely placed in position, and when I fit the boiler bands that have been painted, everything should look good because the boiler wrapper is flapping about a bit. Outside the steam workshop, Dave is currently performing a steam test on this engine. The engine's had a hydraulic test, and now this is the steam test to make sure that everything works okay. John and Simon are here too, and this is John's hand that's currently winding the reverser into reverse. The engine requires 1 or 2 minor adjustments and then it will be fine.
Pressure's definitely coming down at that.
Time to let the fire go out now, and there's still some steam in the boiler, just enough to turn the wheels on the rolling road. Sometimes engines seem fairly jerky on the rolling road because there's no flywheel effect. If these wheels were on the rails and the engine was going down the track, then it would be a lot smoother. On a steam locomotive, the main flywheel effect of the wheels is nothing to do with the balance weights, they're just there to counterbalance the mass of the connecting rods. The inertia or flywheel effect on a steam locomotive is caused by the weight of the locomotive being on the wheels and the wheels rolling along the track. And often the smoothness of running of a miniature steam locomotive is interrupted by the axle pump. I'm going back into the workshop now, but I can't do much more on the V1 until I get the boiler bands, so I thought I may as well repair this. This is a county class 3.5 inch gauge Great Western engine. The regulator leaks and it's been subject to some ultraviolence. The first job is to carefully drill out this sheared off bolt on the boiler backhead flange. Although you can't see it, I have a very small centre drill fitted into this electric drill, and by carefully manipulating the position of the centre drill, I can drill a pilot hole exactly in the centre of the sheared off bolt. Then I change the centre drill for a twist drill, which is tapping size for 6BA, and I drilled out what was left of the broken bolt. Originally, the regulator backhead gland fitting was held in place onto this flange using 6 7BA cheesehead brass bolts, which are more than strong enough to hold the regulator gland fitting onto the boiler bush until you come to want to remove it, and then there's a good chance that the bolts will shear off in the hole, which is what happened here. It's not good to use brass bolts, and it's not good to use steel bolts. For a job like this, I would normally make the bolts from pieces of phosphor bronze, which is a good bit stronger and doesn't rust. Obviously, this tapping sequence is speeded up, and just for the record, I'm using steam oil as a lubricant. The last person who worked on this boiler would insist on using mole grips, so once again, just like the front bush, I reprofiled it in the lathe. And to my surprise, mole grips had even been used on the gland itself. Very, very strange, as it was notched to allow it to be removed easily. I've temporarily fitted some dome head brass bolts in position, just to show you how it fits, but I'm going to use hexagon head brass bolts. Brass bolts are not brilliant, but they will do the job in this case. And then I'm going to make an entirely new regulator assembly. That way the boiler can be given a hydraulic test. And after all this work, I really hope that the boiler passes the test. That's it for now. Thanks for watching, and I hope you found it useful.